Denise? Denise, this is Joanna. I wanted to know if you'd like to get started.
Yes, absolutely. 10:30. Go ahead.
Great. Okay. This morning, we'd like to welcome everyone to the RITIS Probe Data Analytics Suite User Group meeting. For those who are regular user group members, we're happy you can join us again. And for new folks, welcome. Just a few housekeeping items. There is some information in the chat pod for you. You can use the, you can access the audio through your computer, or you may use the phone number that was provided in your registration confirmation and is listed in the chat box. Participants will be in listen mode throughout the webinar. If you are using your phone audio and you have any questions, you may press *0 to speak with an operator. Justin Ferry has provided his phone number, 484-557-7009, if you have any difficulties with the web or audio application. This webinar is being recorded, and presentations will be posted to the Coalition's website following the meeting. All participants and registrants will receive a link to the presentations once they are posted. Since participants are in listen-only mode, we're going to ask that you use the chat box for your questions. They will be monitored and then answered at the end of the presentation or at the end of the webinar, depending on how our time is running. A question and answer summary will be provided along on the Coalition website to all the participants. At this point, I'd like to turn it over to Matt Glasser from Georgia DOT. He's one of our user group co-chairs, and we're happy to have him. Matt?
Thanks, Joanna. So my name is Matt Glasser. I work for the Georgia Department of Transportation. I'm very happy to be welcoming everyone here today. Just a quick overview of what we're going to be doing. Obviously, I'm introducing everyone. We will be getting an update from Denise about what's going on with the Coalition. Shortly thereafter, we will get 3 different presentations from Greta Ryan, Mark Franz, and Michael Pack. Shortly thereafter that, we'll go through questions and answers, and we can certainly, time allow, we can try to do that after each presentation and then finish it up. So getting into the speakers, our first speaker will be Greta Ryan. She is a senior planner at the Richmond Regional Planning Organization. And she'll be speaking to us about integrating RITIS's PDA Suite analytics into Esri's ArcGIS platform. Greta earned her BA in geography from the University of Connecticut. Her first career was in computer programming, working as a systems analyst. She left that career to raise her family. After moving to Virginia, she earned a certificate in geographic information systems from the Virginia Commonwealth University. Greta has worked at Plan RVA and the Richmond Regional Transportation Planning Organization for more than 10 years. Her work there allows her to combine her interest in computers and geography. Mark Franz is the lead transportation analyst at the University of Maryland's CATT LAB. Mark has earned his BA in physics and BS in astronomy from the University of Florida, his MSCE from West Virginia University, and his PhD in civil and environmental engineering from UMD, with an emphasis in transportation engineering. Currently, Mark is the lead transportation analyst at the CATT LAB at UMD, where he is developing and improving online transportation analysis tools and visualizations for public and private sector clients. And finally, is Michael Pack, the University of Maryland CATT LAB director. Obviously, that's at UMD, where he works to make transportation data more easily accessible and usable by ops, planners, and researchers. He has previously worked at the University of Virginia and Oak Ridge National Laboratory. Today, we have close to 135 registrants for this particular user group, and close to 70 agencies participating. We're continuing to see these numbers grow. We're very excited about that. So let me hand it over to Denise to give us an update on what's going on with the Coalition.
Thanks, Matt, and welcome everybody. Good morning. As I'm sure you know, the Coalition sponsors the RITIS user group meetings. So at the beginning of these, we try to provide you with an update of what we've been doing in the past and where we're going forward. So on the screen right now, we have some of the recent meetings that we've had within the past since the last time we met. We've done a lot with Waze. We're managing the TDADS congestion pie chart project, which you're going to hear a little bit more about from Mark later after Greta. And we held a heavy towing exchange with New England, with Quebec, Eastern New York, Massachusetts, Connecticut, and Vermont, to talk about better ways to implement incident management in TIM. We also, just last week, held a webinar, an ICM webinar and an artificial intelligence webinar with Delaware DOT, as well as Caltrans. They provided a great update on some open source concepts they're working on with ICM. So some of the upcoming meetings that we're having within the next couple months, next month in March, we have our annual traveler information meeting. We're going to be talking more about merging technologies, how New Jersey has integrated Alexa into their 511, different technologies such as that. We also have our annual strategic planning session to provide our input into our work plan for next year. And then we have what we call our Southern Hogs Exchange, which really talks about hurricane evacuation and some of the strategies that are used there, and then followed up by a RITIS user group meeting in May. Lots going on. A couple other things before I turn this over to Greta is in the box under files, I believe, there's 2 documents that are available for download. This is a project that was just recently completed. It was part of a grant we had. It's called Optimal Traffic Monitoring. This is just the one-page executive brief, but there is also a report, and pretty much it's a reference that's designed to help agencies if they're re-examining like how to architect their traffic monitoring and management systems, so using multiple data sources. So the brief here, as well as the report, talks about levels of fidelity, data sources, types of design of the monitoring system, things like that. So you've got conventional sensors, commercial probe data, re-identification data, or HRCD, high-resolution controller data, and there's discussion about each, as well as at the bottom, you'll see the emerging leading-edge technologies that are moving forward. So this is a new deliverable that we just have made available to the members. You can get it on our website, or you can download it out of the box during this user group meeting. And then lastly, we have the Vehicle Probe Project VPP Marketplace. This is where states are able to buy probe data from INRIX, TomTom, or HERE, as well as some of their ancillary products at a discount as being a member. We have a new RFP that's in the process of being written. The target date is to have it operational by July 1 of next year, and it's going to look at not only the probe data, but different ancillary products. We're looking at a revamp of the validation and analysis process we do, as well as updating our data sharing and use agreements to that. We're in the process of right now holding vendor meetings. We had an initial kickoff with the vendors. We are going to open it up to other vendors as well to see what we can get for proposals and responses. The technical requirements that we used for probe data are under review, and I'm currently doing outreach to the states to staff the steering committee. So if there is interest in becoming part of a steering committee that works at VPP III, please don't hesitate to send me an email or to give me a shout on the phone. So coalition's been very busy. By the way, the one last piece of information that this is the last time that you will see the logo as the I-95 Corridor Coalition. We have been rebranded, and at the end of February, we are becoming the Eastern Transportation Coalition. We have new member states from Alabama and Tennessee, along with Vermont, and after 25 years, our executive board has looked at a rebranding. So next time you see us, we will be called the Eastern Transportation Coalition. So with that being said, let me turn this over to Greta to talk about integrating RITIS-PDA Suite into Esri's ArcGIS platform. Thank you.
Thank you for asking me to present today on how I use the RITIS-PDA Suite and then how I presented the data in an ArcGIS story map. I work on the congestion management process, commonly known as the CMP, and through the CMP, an MPO collects congestion statistics and develops strategies to manage that congestion. The RRTPO's congestion management process has greatly improved over the years. The first improvement was when the TPO began using the INREX vehicle probe data. Then the RITIS-PDA Suite allowed for greater analysis of that data. And then finally, the data could be presented in an engaging manner using the story map format. When the INREX data was first available, it was a very large data set and difficult to work with using Microsoft Access and Excel. Therefore, to make the data set more manageable, I chose to analyze the month of March, and my analysis was limited to calculating the average travel time index for the AM and PM peak hours. The 2011 CMP was a printed report, and the congestion data was presented through maps like these, showing the average PM travel time index and level of service. And since these are hard copy maps, the information is limited and it's hard to read. In 2014, I began working with the RITIS-PDA Suite. With the PDA Suite, I could now analyze congestion in so many different ways, and the data generated was great. I used all the tools and collected a lot of data on congestion in the Richmond region. Now that the analysis was so easy, the hard part was deciding which tools to focus on and how I was going to present this data. I ended up using trend maps, performance summaries, and bottleneck rankings, while focusing on the metrics of travel time, speed, and congestion. However, in order to have data which could be used in the CMP charts and maps, additional calculations were necessary. This is an example of the trend map data I downloaded and the columns I calculated on the right. The data from the tool gave me the TTI for each 15-minute period during the day. However, I wanted to know the maximum TTI during the AM and PM peak hours. And once I found that maximum TTI, I wanted to know the time at which it occurred. For each of the trend map metrics, I calculated similar statistics, such as the slowest speed and time of occurrence, the lowest percent of free flow, and the percent of peak hours which were congested. Each of the trend map Excel sheets now had data I could use in the CMP. The 2016 CMP included this additional data, and the report was more informative than the previous one. The charts contained a lot of data, but the information on the maps was still hard to read. These are examples of the charts, the maps, and then the bottleneck ranking reports were new in this CMP, and the members of the policy board showed interest when they saw this bottleneck data for the first time. When I began working on the FY20 congestion management process, I wanted to present the data in an interactive format. With an interactive format, I could show more than one aspect of congestion at a time on a map. And what I was hoping such a format would engage the policy board and get them talking about congestion in the region, and that's why I chose a story map. Esri, the largest provider of geographics software, developed the story map platform. And story maps are easy to create, easy to share, and easy to use. Since they're web-based, they don't require special software or logins for the public to view them. By the time I was developing the FY20 CMP, they were accepted by Plan RVA as a reporting format. And now I'll show you the story map with Justin's help. Just a moment. This is the story map on the congestion management page of the Plan RVA website. And I think the best way to present the information in a congestion management process is interactively. But if necessary to have a PDF or a printed copy, the story map can be shared by using the share icon up in the corner. The story map starts off just like the previous CMPs with an explanation of what a CMP is, a map of the TPO study area, and a map of the CMP network. The interactive map of the network allows you to zoom in and see exactly which roads are included in the analysis of the congestion. And you can look at a pop-up to see exactly which road it is, or you could also download a list of the network. The CMP also reports on performance measures, and this chart was created using data from the Performance Summary tool. I ran the performance summaries, selecting months as the time period to analyze, and the AM and PM peak hours as the time range within each period. I ran the performance summaries separately for several years and then compiled this data for a 4-year comparison. The CMP also covers the federal performance measure of system reliability. And the data for this map on system reliability came from VDOT. I created additional fields in order to categorize and report on the data. The red segments are the unreliable segments for 2018, and the status of a segment overall over several years is important. So the pop-up tells you if there's been a change in the reliability over the years, and it also gives you the level of travel time reliability for each of those years. The AM congestion section starts with an animation of congestion to give you a general picture of how congestion forms and dissipates over the course of peak hours. The animation is the trend map analysis downloaded as a GIF and then clipped to the peak hours. The interactive map shows more data from the trend map analysis. The sidebar on the congestion maps give a basic description of the information on the map and on instructions on how to interact with it. There's also, these maps are hard to work with on a demonstration. There's also examples of the travel time index and planning time index, so people unfamiliar with TTI and PTI understand how the congestion shown on the map is being measured. And the pop-ups list the statistics that were calculated from the data downloaded for the different trend map metrics. The bottleneck map was created using the bottleneck ranking tool. The map includes bottlenecks which are recurring during the AM or PM peak hours. And again, the sidebar gives you a concise description of what's on the map. I used the Latin long coordinates from the bottleneck ranking data to map the head of each bottleneck. The information on the segments joining the bottlenecks come from the trend map analysis. I selected segments surrounding the bottleneck heads based on whether they were part of the bottleneck, and I created additional fields to categorize the level congestion experienced at the bottleneck. And the pop-ups list the maximum TTI and the time at which it occurs, and shows the AM and PM statistics for the bottleneck. And at the end of the story map, There are links to the corridor charts and the bottleneck reports, items which were also in the previous CMP, and much of the data in those reports is available in both Excel and PDF formats. And I'll go back to my my slides. Thank you, Justin. So overall, the TPOs received positive reactions to the story map. And when the CMP was presented to the RRTPO Policy Board, the story map generated questions along with a discussion of congestion in the region. And that is precisely what I hoped the story map would do. From the discussion, it was apparent that the next CMP should utilize INREX XD data because of the possibility that some congestion had been masked due to the long TMC segments. Different time periods will also be analyzed to capture weekend or extra peak hours. This is the direction that the Commonwealth of Virginia is taking in analyzing congestion data for the statewide plans. And the next CMP will also utilize the newest features of GIS story maps. So here is my contact information and a link to the story map, and I'll be glad to answer any questions.
Thanks, Greta. Looks like we had a few questions in the box. So to kind of go back, first one was, can you offer some insights on how you segment the freight trucks in your CMP?
And what was that question?
Can you offer some insights on how you segment the freight and trucks in general in your CMP?
The freight and truck, we didn't cover those specifically. We didn't separate those out.
For me internally, I guess, I'd start off by asking too, how has this changed the conversation with your folks internally as well as externally?
Now they can really see what's going on and realize what data is there, and so can ask more questions and dig into things. And that's what happened at the policy board meeting. They started discussing the different congestion, and we have to go back and do more analysis to answer their questions.
Another one was, if you would, just shed some light on how you conflated the TMC network to the Esri network.
I did not do that. I was mapping everything using a TMC network. So, but I did have to do a little work ahead of time to say which roads the TMC is related to, but I'm still just mapping on a TMC network.
Okay. And then Michael asked, kind of similarly, can you talk about how complicated the effort was just to create this story map? Is this code free for other people to use? I guess just kind of walk through that process that you all went through to get it going.
If you have an Esri license, it's part of that license. You can create story maps. And a story map is basically very easy to create. You create a shapefile, and then you have to put that shapefile into a zipped format and just bring it into your story map. And then like any other map, you would symbolize it and work on the pop-ups of the data. So it's kind of important I was creating a lot of the data in Excel to link to the shapefile, which I then would zip and bring into the story map. And it was really just bring it into the format. It's very simple. That's
so
to
what
get
kind of, sorry, go ahead. I didn't mean to cut you off.
Sorry. That is for each of those maps I showed you that were interactive. And then putting it into a story map, there are templates and other instructions on how to create all the other types of things you can do with the story map. This one is a cascade story map, so it just flows from one to the next. Those sidebars are very easy to create. It's very intuitive.
So, and following up on that, it looks like there was a few questions in terms of just what the time estimate, was in terms of how long it took to put that together for your staff.
I couldn't really say, but I would say it was very similar to like formatting a report and getting all your information into a written report. Really nothing much longer than that.
Okay. And then going back to a question we had a little bit earlier, in regards to the freights and trucks, did you mention truck time, travel time reliability? I think that's what folks were interested in.
I had mentioned the level of travel time reliability, the LOTAR, the other side of this TTTR. And that data I got from VDOT. So you could get your truck travel time data from your DOT. Federal Highways has also made a mapping application where you could download the data from that to put into a story map. And I know they had the LOTAR. I think they had the TTTR.
So those are some really great questions. Before we move on, does anyone else have any more before we get into Mark's presentation? See folks typing. We'll wait for them.
And Matt, if you want, you can also come back to it at the wrap-up section. If it's sometimes with the technology, it takes a while with the typing to come through. You always have that option as well.
Yeah, sure. Yeah, let's go ahead and do that. So I guess right up next we have Mark. So let me hand it over to Mark to get going with your presentation.
Thank you, Matt. Can everyone hear me okay?
Sound great.
Okay, good. Yeah, so today just providing an update on our progress on our Transportation Disruption and Disaster Statistics project that's being sponsored by the Bureau of Transportation Statistics. So just quickly today, kind of going to go over a background of the overview and motivation for this project. We had a sort of more in-depth presentation back in November, which I think I see some familiar names here, so it's not my intent to go into too much detail on that, just kind of a rehash on the methodology and the data that we're using. Then we have some initial results that we've developed for 2 states. We did the entire year of analysis for Maryland and Colorado. So I'll show you those and compare them with the old pie chart from 2004. And then sort of the last part of our methodology task was to develop some strategies for assessing and presenting results for multi-factor causes of disruption and congestion. So I'll kind of go over our methodology and results for that, and then finally discuss the next steps related to this project. So just quickly then, some background on this project and sort of the motivation for the BTS to pursue this. A lot of people might be familiar with the congestion pie chart that was developed by the Texas Transportation Institute and Cambridge Systematic back in 2004. So at the time, it was pretty groundbreaking work. They collected data as much as they could around the nation and then modeled the rest to develop this pie chart, which a lot of people are still referencing to this day and using it to make decisions on their infrastructure investments. But obviously this is, not only is it outdated, but BTS realized that there's a lot more data out there now that we probably don't have to model it. So we responded to the RFP and were awarded this project. So we have the objectives here of upgrading this pie chart using national level data. We're analyzing the entire national highway system. and I'll talk a little bit about the data sources that we're using for that on an upcoming slide here. And we want to make the tool that's interactive and easily accessible to people so that they can start to get a sense of what the overall breakdown of congestion and the causes of congestion and disruption are. So the end product will be to analyze a full year of data from August of 2018 through July of 2019. That will present the causes of congestion pie chart for each state, as well as rolled up into a national level statistic. And of course, all of our work is being guided by a steering committee, the methodology and the results, and what the end product will ultimately look like. Feedback was provided by those stakeholders. For our analysis, we had to go through some tasks to identify potential data sources that we could use for assigning assign congestion to particular causes. So you can see ones that are hashed out here. I'm not going to go through each individual one, but we have a lot of data in hand here at CATT LAB, but we have a caveat for this particular project that the data needed to be comprehensive to cover that time period of August of 18 through July of 19 and the entire NHS. So while we have some really good detailed data that we're getting from some of our partnering states from the coalition, we don't have that level of detail for every single state. So for that, we are relying on WAYS data for a couple of these items, particularly the locations of work zones and incidents. Our weather data is a task that we have been planning to do. Even though we've been getting the radar data, we're now actually conflating the radar data to the TMC network so that we know for at any given minute if there's any precipitation and at what rate it's in the atmosphere, at least the reading is. So that was a unique and good contribution from this project. Holiday travel, we're just using the calendar, so it's not just the days of the holidays where they travel tends to be light, but also the days leading up to it. So for instance, the Wednesdays before Thanksgiving is a heavy travel day, so we're including those in the analysis. Traffic signals, the location of the traffic signals on the national level, there's a layer in OpenStreetMap that we've decided to use. And then we also have a couple other categories that we're reporting on. The multiple causes, which I'll talk about, are our data sources for that, and then unclassified disruption. And of course, the first step of this is to identify when and where there's congestion, and for that, we're using the probe data, which is also the basis for identifying the first category there, which is the recurrent disruption or congestion. So this is just a logic flowchart of sort of what's under the hood of our data processing and analysis. So we start by detecting disruption, and for this we're using the definition of disruption that we've been including in our bottleneck tool, and I'll talk a little bit about that I think on an upcoming slide, but it has to drop below 60% of the reference speed and be sustained for at least 5 minutes for it to activate a bottleneck or a disruption event, and then we start quantifying the user delay cost associated with that. So the first step is to detect a disruption, and then we ask the question if it's recurrent or not. If the answer is yes, then let me pull up my arrow, it might be helpful. We come to this node, the green node. We ask if it's in a normal pattern. So it could be, it falls within the time period that there's normal, PM peak recurrent congestion, but maybe on some particular day it's 20 miles per hour slower than historically it is. So we ask this question. If the answer is no, it's not abnormal, it's just a normal pattern of recurrent congestion, then it's just called recurrent congestion, and then we quantify the user hours of delay. However, if the answer is yes here, then we start to look if there's multiple causes going on. So it would be recurrent congestion plus something else, and we go up to this box. In a similar fashion, if it's not recurrent disruption right off the bat, we start to look for other causes. So here's the incidents, whether it's work zones, holiday travel, and then signals. And we determine what the cause is, and then also recognizing that there could be more than one impact going on. So understanding what that is, or it could be that we don't find any event there and we have to classify it as unknown disruption. and then we put, quantify that as then the user delay cost and put that in the appropriate bin. So the pie chart's based on user delay cost, and then we slice up the chart based on the various categories that we have. So we did that to 2 states so far. So we're at the point where we're almost wrapped up with our methodology, but wanted to start assessing some of the states that we already have the data for. So we did that for Maryland and Colorado. So this here is the results for Maryland. So you can see recurrent disruption, still one of the larger slices of the pie as it was back in 2004. Signals got to be quite a bit bigger than they were in 2004, but I'm going to put them side by side at the end so that you can recognize these differences. And then in a similar fashion, we did the analysis for the state of Colorado. Again, recurrent congestion was a biggie, as was signals, and then multiple causes jumped up quite a bit. So when we put this side by side, and keep in mind that the 2004 study didn't include multiple causes, and nor did they have the unclassified slice of the pie chart. So we kind of took the liberty to relabel some things in the old chart so it's consistent. But things that you'll notice here is that, as I mentioned, the signals in the 2004 study was just 5%, and we're seeing it, above or near 20% for both Maryland and Colorado. The recurrent disruption is a little bit less than what it was in 2004, but it's still the most significant piece of the pie chart. And then, as I also mentioned, the multiple causes is a big slice of the pie chart in both Maryland and Colorado, and it was something that was not directly included in the 2004 study, so it's hard to do that direct comparison. But you can see that there's differences here. We have a slightly different methodology, and we're using real-world data, not simulated, could be part of that explanation of why we see the differences in them. So just wanted to talk briefly about our methodology that we developed, because recognizing that multiple causes is a pretty big category when we look at the 2-factor and 3-factor and even 4-factor causes that are possible at looking at all the possible combinations. So we wanted to come up with a way to report on some of the top or most prevalent multi-factor causes that we could roll up for at a national level and present for each and every state. So for us to do that, we considered a couple of things in selecting the states for this analysis. First, we needed to have that 1-minute probe data in hand for the time period of August 2018 through July of 2019. Was an important one. So we used that, and then to consider any seasonal variation, we picked 4 months that represented each of the 4 seasons, so February, May, August, and October, and analyzed all of the multi-factor combinations and then reported back on the top multi-factor combinations from these states. So this table presents sort of the findings of this analysis. So again, the goal was to discover the top 4 multi-factor causes that we're ultimately going to report for each and every state and roll that up to a national level. So again, we analyzed these 7 states that I mentioned on the last slide. And what's shown here is the left column shows the combinations that were the most prevalent, the top 6 of them actually. And then the score that we gave them is based on the occurrence of that combination being in the top 4 for each state. So incident plus weather was actually in the top 4 for all 7 of these states, where signal plus weather was in the top 4 for 6 out of the 7 states and so forth. So you can see that these 4 2-factor combinations were the most prevalent in the states that we analyzed, and will be the ones that we report on for the full national level study. So then the next steps is really just to process the national level data. So we're working with BTS, who are working on finalizing a contract with INRIX to purchase the 1-minute data on the National Highway System for this time period so that we can apply our methodology to it, which will ultimately be fed into a online tool that'll be interactive, so you can click on any of the slices of the pie chart to learn more information about the temporal breakdown. So you can search by individual states, as shown on the left graphic here that's rolled up into the national level. And then when you start to drill down to each of the individual states, when you point and click on one of the pie chart slices, it'll give you the breakdown, the contribution of that particular cause of congestion. In this case, we're showing incidents, their contribution over each of the months within the analysis period. So that will all be presented and made available to you all so that you can go in and interact with this tool and learn some more information about the cause of congestion within your state. So that is all that I had. I think I'll turn it back to Matt and Denise.
All right. Thank you, Mark. Just a quick update, too, for the group. Mark's presentation deals with the end of the year one of the work that they're doing, and we're moving into year two. And so through the steering committee, we've actually done some polling questions and some helping provide them with direction. So this polling question we'd like to bring out to all of you is that how would you envision your agency using this data tool? So you can check all that apply. It looks like folks are already on their voting, but we wanted to get a sense of how you might use this tool, whether it be for congestion management, work zone management, significant event planning, traffic studies, or other. And in the other, you can, couple things. You have the opportunity to put that in the chat box if you so choose, or we can certainly do outreach via email to you. But besides the 1 minute data mark and the purchase, do you have a sense of, I know that the last time the steering committee talked about doing much more of a deeper dive into the existing study. Do you have a sense of where the project's going to go in year two? As an update?
Yeah, so there's two general paths that BTS is interested in. The first one is the deep dive tool, which I'll talk more about in a minute. And then the second one was sort of doing a similar analysis for other modes, whether it was air, rail, or maritime. It seems like most of our stakeholders, as well as the BTS, are leaning more toward the deep dive analysis on the highway mode, which would allow us to create a tool that would allow the users to go in a very PDA style query type page where you can select specific road segments and time ranges to drill down to those road segments and times that you're most interested in to create the pie chart for that selected time and space range. So that's the one that we're leaning toward, and we're kind of in the process of scoping out the level of effort to do that so that we can work with BTS to see if the budget is in line with what they had in mind for phase two.
Thank you, Mark.
Welcome.
Looks like the poll is closed. Matt, I'm going to turn this back to you now. Thank you, Mark. It was a great presentation.
Appreciate it, Denise. Well, I'll start. Mark, when did you say that you thought that you guys were going to plan on, I guess, finalizing that and getting the rest of the state's polls or results pushed out to RITIS?
Yeah, we're hoping sometime this summer. At this point, we're kind of just waiting for the data to be delivered to us so that we can process it. So assuming that comes through within the next month or so, we think that it'll take 3 or 4 months to process the data and get it into the online interface. While we're waiting on that, the interface is being developed and kind of will be ready. And I think that we're going to put the 2 states that we already have done, Maryland and Colorado, in it and share that with at least the BTS. But the rest of the data would likely be this summer sometime is what we're aiming for.
Great. And just curious with your all's methodology, how do you go about determining, for example, that it's traffic signal timing that's causing the problem on the arterials rather than something else?
Yeah, so we use we refined, I'm not sure if I fixed it in my presentation, but we refined the label from traffic signal timing to just traffic signals, because we can't tell if it's a timing issue or if it's at its saturation beyond its capacity. But in any case, we look for the segments that are approaching a signalized intersection from which locations we got from the OSM map. So if it's near there, we think that the signal had some contribution to that delay. It's possible that there's other events like a crash or potentially a work zone or something like that that's there. And in those instances, it would be labeled as a multi-factor cause. So it's really just based on the TMCs that are approaching an intersection, which again is another thing that we had to modify because traditionally we've been mapping incidents and they're just on one side of a roadway, one TMC is detected. When you look at an intersection, for instance, if it's a four-way intersection, there's 8 TMC segments that have its start or end point there. So we had to figure out a way the ones that are approaching it will be the ones that we would look at, not the ones that were leaving the intersection, if that makes sense.
Yeah. So if you guys, can make a suggestion to, all the partner agencies, you said, if we could just get one piece of data from you guys, we think that we could make this a lot better. What would that piece of data be?
Not just sitting here with me, but I mean, I'll let him chime in too, but I think, right now, the Waze data is what we're using for both work zones and incidents. And I think that it's a pretty good data source. It's very comprehensive. But with crowdsourced data, there's always the question of redundancy and data quality. But we did our best to try to, only take the incidents that meet a certain threshold of confidence that we think it's a real incident. So having, more detailed data that comes from verified sources, whether it's historical state police reports or from a traffic incident management program at a national level, I think would be tremendously helpful for us.
Okay.
Nacho's nodding his head in agreement.
Yeah, it looks like Michael's also digitally nodding his head.
Yeah, he has the work zone data. So we're using Waze for work zones too. So again, not having that at a national level is so we have to rely on the crowdsourced, which, Waze works as like data points that doesn't really let you know the full length of a work zone if they have a lane closed for multiple miles. So having those types of details, I think, also would be pretty beneficial.
Let's go ahead and move this over to Michael, because it looks like we're pushing through time, and if we have some more questions that we haven't gotten to, we'll finish it up at the end. Michael, it's all yours.
All right, thank you. So now is the part where I talk about all the stuff we've deployed recently and all the stuff that we are getting ready to work on. So some general updates for the RITIS website. We have real-time weather data that is being displayed on RITIS, and that's generally radar data. We also have forecasted weather data. And sometimes those tiles are rendered slowly and have some resolution issues. So we've just gone in and improved the rendering of all of that, especially at higher zoom levels. So that's a big improvement. I think I mentioned it during the last user group meeting that we'd started to integrate transit data around the country for those who have GTFS real-time and static feeds available. And while we can integrate data pretty easily, the performance of really, really dense bus and rail networks, what was an issue in terms of rendering and drawing those things out. So it's been a lot of work the last quarter updating the speed and responsiveness of those transit layers, visualizations within the RITIS program. And that's what this picture is over here on the right-hand side. This is a snapshot of bus movements on different bus lines in the Baltimore region. For those of you who use the region of interest filters within RITIS to narrow down the data that you want to be seen, we've improved the precision of the rectangles and circle drawings for the region of interest in the system. Most people don't use that, but it's important to a few operations people. We've also added here subsegment probe data onto the RITIS map. That wasn't available before, but that's now out there. And we've just started this. It's not in development yet, but we've finished some user interface designs for reskinning the RITIS look and feel. That's the stuff that's up here at the top. of the RITIS website that helps you to navigate around. It is old, it's clunky, it's a little confusing, so that is being just started right now, but the designs are complete. Another big improvement is we had a lot of complaints from folks that when they were looking at the RITIS map at different zoom levels, they weren't able to see enough roads being displayed all at once. Roads were hidden, and you couldn't get data on them until you zoomed in really far. So now we've improved the density of the data that we display on the real-time map, so you can see more roads colored all at once. And this won't benefit too many people on the call, but we are now working in the United Kingdom, and we've integrated their probe data, and we're working to integrate other data from the UK as well. So you all can see it. Feel free to zoom out on the map and head over to England and zoom in and see what's going on way out there. For traffic view, that's the public version of RITIS, if you've given us permission to share your data publicly. We've updated that portion of the website to now show static CCTV images. So if you have a video that's coming in that's not streaming, it's just an image that updates every minute or every 30 seconds or something like that, those can now be viewed directly on the public traffic view website. We continue to update volume data for agencies. GDOT gave us their volume data. Thank you very much, GDOT. And that's now been updated in the site, as has Maryland's data. And I put these slides together a few days ago, so they're already out of date. I think last night we deployed new volume data for Pennsylvania Department of Transportation and a new national NRICS volume data set. And I have to keep reminding people every time about this. If you are a state that does not see your volume data listed in the volume data provider list over here, that means your volume data set is out of date and really needs to be updated, else your user delay cost reports are going to become less accurate as time progresses. One, because the volumes are just out of date, but the other reason is as time progresses, new segments are drawn or are created by the different data providers. And as those new segments are created, the number of TMC segments that we had volume data for to begin with stays about the same. So the gap between what does have volume data and what doesn't keeps growing, and that causes the reports to not be as accurate as they could be. So please, 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 if you're not on this prior list, reach out to us. We will update your volume data for free for you if you provide to us in the right format. Keep going here. There we go. For those who use the Probe Data Analytics Suite, the dashboard section has a bunch of new widgets. The most recent one that we deployed is a clearance time widget. So if your agency is giving us incident data, you're able to see, you're able to now produce widgets that tell you how long it took your agency to clear each of those incidents. So that's kind of an everyday counts traffic incident performance measure, right? You've got 3 different visualizations that you can choose from. The top visualization just breaks down by year and by month the average clearance times of all the incidents and events that you responded to in your state. And you can kind of see the trends. Are things getting better? Are things getting worse? The next one breaks down the incident clearance time by time. So it's like a histogram. So how many of the incidents cleared between 0 and 30 minutes, 30 to 60 minutes, an hour to an hour and a half, and so on and so forth, by year, by incident type. And the bottom one shows you the variability. So these box and whisker charts that give you the average plus the 25th, 75th, and 5th and 95th percentiles. So check these out. Go ahead and create them for your agency. As long as we're getting your incident data, these should be available. Thanks to PennDOT, who funded some of our signal analytics performance measures tools. They've actually funded us to continue to improve these tools. So we've now got some new visualizations that allow you to see the percentiles and the actual amount of time that you're having an increase or a decrease in congestion and reliability and travel times out on your road network. They've also added some new features to the Signal Performance Measures map that lets you go in and click on each individual segment. And each one of those segments will then give you AM peak or PM peak period performance measures telling you, whether your travel time index is increasing or decreasing between the date ranges that you've selected in the query form. We've also done a lot of work to improve XD road search. This applies to folks who use INRIX data and the INRIX XD. That's their finer granularity data for the road network. It has historically been difficult, even though there are a lot of XDs, to go in and choose starting and ending points based on intersecting roads. So we've done a lot of work to go in and create some new metadata to figure out where all the intersections really are and how they align with the different XD segments, and put that into the tool. And then the next thing I want to talk about is our trips and trajectory analytics. We've discussed this in the past, but we have a series of tools that allow you to go in and analyze people movement, people and freight movement. That's our trip analytics tool set. And within the trip analytics tools, you have this OD matrix tool, a segment analysis tool, and now brand new is this route analysis tool. So this tool lets you look at the routes that people are taking to get between point A and point B on some geography. So I'm going to just show you what this tool looks like. I'm going to go in and look at Massachusetts, and I'm going to go and look at Worcester, Massachusetts. And I want to know what routes people are taking to get from Worcester over to the Boston area, Boston region. Go down and choose Boston. Come on, Boston. There's Boston. Choose Boston. So 2 different regions. I'm going to now choose a time period. Maybe I just want to look at Mondays through Fridays. Maybe I want to look at all of 2019, and I'll go from like 5 a.m. to 10 a.m. So, what routes are people taking from 5 a.m. to 10 a.m. Monday through Friday for 2019. You hit submit. There's other filters you can do as well for light, medium, or heavy vehicles. I won't actually run the query right now because it's a ton of data. As big as the probe data sets are, this trip data set is orders of magnitude bigger. So this query might take 15, 20 minutes to run. I've already run the query before we start the webinar. So this is what the results look like. At the very top, you've got a list that shows you the ranking of the most popular to the least popular routes to get from here to there. And whichever one you click on, that's the route that then gets highlighted. You can zoom in and you can see, the majority of people are taking this particular route. Put your mouse over, it gives you information about, how many trips use that particular route. And then you can go in and you can visualize the variance. So here I just clicked on the second one, and I've got them both. So the second one comes down here, turns around, joins with the main route. I'm just going to keep adding a bunch of these. I mean, there's too many to really add all of them, but I'll add like the first 15 or so and go in. And what's really neat, zoom back out. So there's your top 15 routes that are all displayed all at once to get from one spot to the other. And there's something neat down here. Let me go back to the top of the list. So that's our, the blue route, that's our most popular route. If I zoom in down here, the 14th most popular route comes off here of this, this particular road, comes down, joins up with this road, but there's all these other trips. See, there's like 14 trips, 27 trips. And then it joins with this park and ride lot. And it picks up a whole bunch of extra trips that then turn out and go and join up with the other main route that most people take. It gives you some other metrics. It gives you the average travel time, the minimum and the maximum travel time, and the reliability of the travel times. And these are, actual experienced travel times. This is the amount of time, these individual trips actually took to get from point A to point B, which is really cool. And you could switch the origins and destinations and see the return trips as well and see if people are taking the same routes or not. So this is brand new. Again, it's only available to agencies that have purchased this particular data set from a data provider. But it's a pretty powerful tool, and we'll continue to make updates and improvements to it as time goes on. All right. So what are we working on now? We are still pulling in detector data from a lot of different agencies. That's sensors, inductive loop sensors, or side-fired RTMS, or whatever. That's collecting volume, speed, and detector occupancy. Those tools are pretty out of date and pretty slow. So we are modernizing those, and we're getting ready to roll one out later this month. The entire suite won't be updated, but the first downloader tool will be updated later this month. So look out for that. We've also had a lot of requests for updating our tutorials and creating more tutorial products for the RITIS platform in general, not just the Probe Data Analytics Suite or Detector Data Analytics Suite. So we're putting together a bunch of videos, and there's going to be a brand new video tutorial page that you can go in and watch demos of the tools and learn how to use them. We're also putting together a lot of new templates. So for those who've been using the Probe Data Analytics Suite for a long time, we have a tutorial, a template for travel forecasts. We have a template for before and after studies. GDOT has created a template too that we share up there. We're also putting together templates for work zone audits and after action reviews and a few other things. It's going to make it easier for you to produce communication documents that you can take to meetings and hand out to elected officials and whatnot. And I mentioned it earlier, but we're just now beginning work on the reskinning and modern user interface of the RITIS platform in general. And you saw the causes of congestion presentation that Mark and Nacho gave earlier today. While we still got a few months to actually go and crank through all of the numbers for all the states, we're still going to be rolling out the user interface for the states that we have data for, fairly soon in the next couple of months. So be on the lookout for that. This is the part where we like to stop and listen to your needs. We particularly want to hear what's not working within the suite, or if there's any sort of features that you wish existed that don't exist. If you remain silent here, you don't get anything new. You don't get what you want. So we really encourage everyone to speak up and be vocal. And we do have small pots of money laying around that we can use to build in some new features. And if we don't have enough money for the feature you want, we can at least discuss it in an open way with all the different funders of RITIS to see if anyone's willing to fund it on your behalf. So please be thinking of things you want and start typing them out, and we can discuss them. And while we're waiting on that, maybe there's some questions that have come in that we need to focus on. Let's see. like Taruna had a question. She's asking, is there a cost to use this data? How much? I assume that was for the trips data. Taruna, so yeah, there is a cost to get access to the data. So Massachusetts is purchasing that data today. Maryland, I think the MPO in Rhode Island's purchasing it. There's a few others. There is a cost to it. I don't know what the cost is. Can reach out to Denise Markow. She can hook you up with the data vendors to discuss pricing. But once the data is purchased, we then take that and we integrate it into our tools. Let's see, Catherine Johnson. Did anyone use the following detector tools in the RITIS toolbox? 1, detector tools, detector profile, detector tools, health summary. 3, detector tools, launchpad, and 4, detector tools, road profile. I guess that was a question to the larger community and maybe not me. Most of our users of this tool come from Florida. I think they use it more than anyone else. And then we have a few researchers at universities that grab that data. But it is slow and cumbersome right now. So I think you'll notice some improvements once we deploy the new one. But if anyone else uses it, please speak up. Let's see, Zhen Mao, is there any plans to replace Flash Player using the PDA Suite? There is no Flash Player required for the PDA Suite anymore. So that is not an issue. We finished that rollout maybe 5 or 6 months ago. Ben Jacobs, map selection of segments, geographies, and more tools. So when you say map selection, Ben, I assume you mean being able to use your mouse to click and drag and grab roads that you're interested in. I think that's what you're asking, but please type more and feel free to send me an email as well, and I can call you and we can talk about it. We don't have the ability to listen to everyone on the line, right? That's
No,
a question to
unfortunately
Jeff.
Right.
Okay. So, yeah, Ben, I'd say let's schedule a call and we can discuss and figure out, exactly what it is that you're looking for. And then we can try to prototype some things and bring it back to the next user group and show it to everyone and see if that's a desired feature or not. I see there's a second to the map selection. Yeah, the text selection can be very clunky. There is a map selector today, but it's kind of an all or nothing thing. You draw a box around a cluster of roads and you get everything. We have a few thoughts on maybe how to improve that, but our thoughts may be different from what you're looking for. So we should definitely talk about that. Zhen Mao, since you've also seconded this, maybe you could join in the call with Ben and I, and we can kind of discuss what it is that you're both looking for. If anyone else wants to be a part of that discussion, send me an email and we'll do a conference call about that. Catherine Tully, does RITIS have any plans to introduce an API for users to download data programmatically? The answer is yes, and we do. So there is an API, it's called RITIS Filter, that agencies are allowed to get access to, and it lets you subscribe to real-time data and ask for some archived data as well from incidents and other stuff. We also have an API for the probe data that essentially allows you to go in and run almost all of the historic queries that you can run directly through the user interface programmatically. So Catherine, if you send me an email, I'll put you in touch with the people that manage that API, and they can send you all the documentation for it. Chester, it looks like there's an add-on here. To add to Ms. Tully's question above, is there a data dictionary available if there is an API? We would like to look at building a black box to read the dashboard that we created. Yeah, we do have a data dictionary. I don't understand the black box and dashboard reference, Chester, but again, send me an email and we can talk about that more, or you can type some more out. Let's see. And Catherine seconds the data dictionary. Also, please send the API
Michael?
to me as well. Yes. Yes.
Michael, if you scroll further up, there are a couple questions from Kelly Wells and Ben Jacobs too that we missed.
Oh, whoops.
Just so you're
Okay.
That's okay. Just be aware of
I'm
it.
scrolling up. Kelly Wells, where can I see the here subsegment data? It is just deployed. So if you turn on the here data, you'll see it. It's only visualized on the RITIS map. It is not yet available for selection through the Probe Data Analytics Suite. That's a whole nother ball of wax that we're working on with Matt. But the subsegment data is visible right now. Just automatically. You don't really have to do anything. And Ben Jacobs, what is the right format? Does HP? Oh, I think this is a question about the format for updated volume data. It's kind of HPMS. It does need to be formatted in the TMC format, and we have documentation on our website that tells you what that format should be. Give me just a second. I will find that, and I will drop the link in the website. While I'm searching for that, Denise or someone else, can you read me the next question?
Sure, Michael. Kelly also asked, is the clearance time defined as incident duration, end time, start time, or a more sophisticated measure?
So there's two different ways it can be classified. It can be classified on the roadway clearance time in terms of when the road is actually cleared and open, and the other is when is the incident ended in terms of like all the responders leave and the agency closes the incident in their system. It's not something where we're looking at when does the travel time and congestion on the roadway return to normal for that time of day of week. We're not doing that level of sophistication yet. Any other questions?
There was one more that was early on, and again, I think this is for the clearance time widget. What is the right format? Does HPMS data work?
For the incident clearance, was that incident clearance or was that for the volume data?
The incident clearance time widget, I believe.
So for incident clearance time, the only thing the agency needs to be providing us is their incident data feeds. And we'll take your incident data in any format. The volume data is a different story. We do require it to be formatted specifically for us to be able to actually do it for free for you. If you can't format it in the way that we're requesting, we'll either talk to you about what it might cost to put it in that format, or we'll find someone else who can help you with that. I just now posted the help file that explains what the volume data format should be. Did we cover everything?
I think we have one more, and it goes back to the question, to the conversation you were having with Chester about I think he meant a blackboard. They have a large dashboard with more than 50 routes, which is too many for a TNC operator to look at, and they're trying to figure out a way to have an automated detection pop up for an alarm.
Ah, I see. Okay, that makes more sense. So we are working with a different state that's not a part of the coalition to actually do speed alerting. So maybe that is something that we could share with Chester and the group about that effort and see if that's something that would work. Yeah, okay, boom, boom, yeah. So yeah, the other state calls it speed threshold alerting. It does require the agency to go in and configure those alerts manually in our system. But once it's configured, you essentially receive an email or a text message when that threshold is breached. It is computationally intensive, to do it, but it is something we're working on. So yes, Chester, we'll send you an email and share that information and see if that's what you're looking for. And if it's not, let's come back to the group and have a broader discussion about what that should look like and whether or not other folks here would value it as well. The more people that value it, the easier it is for us to justify building it. Cool. All right. We're into our agency input session right now. Give it just a couple more seconds here and see if there's any other complaints or comments or questions that anyone has. And also, while you're thinking of that, we're always looking for people to talk about what it is they're doing with the data, what it is people are doing with RITIS, the Probe Data Analytics Suite, or anything else. So, Chester, it sounds like you've been working on something. Maybe it's worth hearing a presentation on that later. If others are doing any sort of work that they think is neat or different or worth sharing, please let us know. Reach out to Denise or myself, and we'll try to get you on the schedule.
Yeah, to echo Michael's comment, I think the strength of this meeting, because it is one of our strongest webinars, is the fact that the agencies can spotlight the work they're doing and others can learn from them. So yes, please bring forward any work you're doing because others really appreciate it.
All right, I'm guessing we've kind of about ended our willingness for people to offer stuff up. So maybe we should move on.
I think so. Well, I appreciate it, Michael. A lot of great feedback and great questions from everyone. I think this has probably been one of the more active sessions I've been on recently, so really appreciate everyone's input and engagement on this. I think that about does it for this session. Denise, do you have anything you'd like to add before we wrap this one up?
No, Matt, I think that was great. I just think the only thing that we can add is that we're all going to take away Chet's new word, boom, in the chat box. Thank you, Denise.
Your contributions are much appreciated. All right, well, with that, we'll give everyone about... We'll give everyone 12 minutes.
I'd like to thank again Greta.
Yes, and thank you to our speakers. We really appreciate it. Everyone, thank you for joining, and we'll be looking forward to seeing you guys on the next user group meeting.
Great job. Thanks, guys. Great.